We're going to take a look at ways to express concentration and then using that to calculate dilution for our solutions. All right, so let's talk in general. Okay? So concentration is how much solute you have in the solvent. If there's just a little bit of solute, we sometimes say it's dilute, but that's still a relative concentration. Okay, if there's a lot of solid in the solvent, we're going to say it's concentrated, but again, that is a concentration. Those are relative terms we use. They're not all that helpful in chemistry because, of course, we want numbers to compare with. So let's look at getting some numbers for our concentration. By far, the most popular way for chemists to measure concentration is with molarity. And yes, as the name implies, it involves a good friend, the mole. So molarity, which is abbreviated by capital M, is the N, number of moles, of the solute. Okay, now watch out for that. That's just the moles of the solute, and we're going to divide it by V, which is the volume in liters, has to be in liters, just like with gas laws, has to be in liters, okay, has to be in liters. Liters of solution. All said and done, what's the volume? And when I pour the solid in with the liquid, or put the gas in with the liquid, or whatever I do, put the liquid in with the liquid, the total volume at the end of the solution is what I use there. All right, so we're going to do an example here, and I'm going to ask you for your favorite color. Yeah, for green. So here we are. We're looking for the molarity, and I like to annotate. So I've got a 3.5 liters of solution, and it contains 1.54 moles. Okay, and I'm asked for, again, what is the molarity. So you want to just easily find the numbers with their label and the question statement, and then we're all set here. So molarity is number of moles per volume in liters. My moles is 1.54, and my volume is 3.5 liters, and it tells me liters of solution. So after I've added the sodium chloride, whatever the volume rose up to when I added the sodium chloride, if it did at all, that is my volume. Okay? So I'm literally just going to take 1.54 and divide it by 3.0. But I want you to see how the labels are going to work out for us. Okay. So the moles has a label of moles, MOL. The volume has a label of liters. When I divide, and I want 3 sig gigs, because I have 3 sig gigs on each of those numbers, I get, it would help if I type in the decimal, because I don't get 44 as a molarity. I get 0.44. Here's the issue with 0.44. That's on the significant digits. And then 0 for my third significant digit. No big deal. There you go. I started with 3 and 3 ended with 3. No big deal. Okay. Here's the label. The label is literally moles per liter, just like that. Now, it's also totally acceptable to abbreviate molarity as capital M. It is the only thing that is both symbolized with capital M and its units, its label is capital M as well. So watch out for that, because you can use it, and that's not, I wouldn't say, oh, I've got 3.50 volume. No, we say what the volume is measured in, liters, milliliters, whatever. Molarity, it does work that way. We can say 0.440 molarity, and molarity is moles per liter. These are identical, equal labels. So here we go. Okay, so that's an example of one possible question. Let's try another one, and I need to clear my annotations here. I should have done that before I got started. There we go. Okay, let's do a new favorite color. All right. So again, number with its label, and here's the tricky part. We can't use quarts. We got to use liters. Now, if we have milliliters, I can convert that to liters, right? Okay. And I've got another number at this label, and then I'm looking for that question statement, how many moles? So my molarity is number of moles per volume in liter. I'm asked for how many moles. I'm asked for the N. Well, right now N is being divided by V, so I'm going to clearly just multiply both sides by V. Close to capital V. The number of moles is going to be molarity times the volume in liters. So here we go. And I'm going to watch what I'm going to do here. I'm going to write molarity not as capital M, but as the alternative moles per liter. That's exactly the same thing. Like saying a dollar is 4 quarters, and quarters is a dollar, same thing. And I'm going to multiply, that's what we are going to do there. I'm going to multiply by the volume in liters, 0.945 liters, and that's just what I want you to see. The liters there and the liters there cancel out. It gives me moles, which is a great label for my answer, right? Yes, of course it is. I'm going to now multiply these numbers, and by the way, 0.300 is 3 sig gigs. That's what all those zeros are there for. There's 3 sig gigs. And 0.945 is also obviously 3 sig gigs. Okay. So I'm going to round to 3 sig gigs. Right now I have 2,835, and I'm going to keep 1, 2, 3 sig gigs. So the 5 tells me that 3 is going to become a 4. So I'm not going to keep that. I'm going to go 0.284. That's my 3 sig gigs. So if I start with 3 and 3, I should end with 3. My label is just a mole, plain old ordinary moles, because the liters have canceled. All right. So there is that example. Let's try the next one. Going to want to take my numbers, find my numbers with a label that's really well, my circle one with the Y. And then find that question statement. How many liters? So liters is the volume. I'm looking for the V this time. So let's talk about that. M equals N over V. Well, here's what I'm going to do. It doesn't help right away, but I'm going to multiply both sides by V. And now my V is still, I don't have my V by itself, so I'm going to now divide both sides by capital N for molarity. So volume is number of moles divided by molarity. Now notice on the formula chart on the test, you're just going to get that M equals N over V. That's all you're going to get. It's up to you to be able to figure out how to solve in all 3 places. All right. Number of moles is 15.9 moles. That's a 1, 15.9 moles. My molarity is 2.25, and instead of writing M for molarity, I'm going to write this way, moles per liter. So check it out. Now the moles cancel, leaving me the liters as my label, which is a great label for volume. Great how that works out. Notice how labels are always there in our numbers to help guide you, let you know you're doing the right work. If the labels don't work out, you're not doing the right work. Okay. Now, by the way, I started with 3 sig gigs there and 3 sig gigs there, so I'm going to go for 3 sig gigs here. 7.07. And the label that didn't cancel is the liter. So there we go. There's my liters, the solution. I can see it really is that easy. Maybe the hardest part is just solving for the V in the first place. Okay. All right, so that's how molarity is calculated. Now that we know molarity, I want to introduce you to another concept, and that is the fact that we often change the concentration into molarity. Like when I want orange juice, I'll go into my freezer and I have a itty tiny can of orange juice, right? It says on the can, concentrated. What's that mean? That means they have a lot of orange juice with just a little bit of water solvent, sorry. What do I do though? I don't just eat it straight out of the container. All right, I'm going to put in a big pitcher and I'm going to add a lot of water. I give you 2.5, 3 cans worth, something like that. All right, so for many reasons, we often concentrate chemicals for sending them places, and then later we're going to dilute them. So we need to be able to know, how do I dilute it to make what I want it to make? So here's our equation. And we have, it looks similar to gas law equation, okay? So we have M1V1 equals M2 liters, M for molarity, V for volume, okay? Here's a little catch. You don't necessarily need your volume in liters, as long as they're both the same. One's in milliliters and one's in liters, can't do that. Don't do that. You want to convert. So liters, milliliters, milliliters, that's good. Liters, that's good. You don't want one of these. That's all. Okay. So let's do 4 examples of these, and I'm going to do the same thing I did before. Let me get a color here, though. I haven't used yellow, but yellow here. So I'm going to first just find all these numbers with their labels. So I got a little one that was like broken here. Okay. And I want the question statement. What amount would be volume? Okay. So I'm looking for volume. I have 2 molarities, that's 2 capital M, and I have 1 milliliter. All right. So maybe make a little list. M1, V1, M2, those are capital M's, by the way. V2. Now it doesn't really matter what I call what, right? Okay. So I'm going to put the first molarity just here, so that you like it. And I'm asking what volume of that. So there's my question mark or my X. Okay. I'm given a new molarity of 1.50, and I'm told I have a new volume. The pairs together. We did this a lot in gas laws. I mentioned all the time the importance of keeping your pairs together. Keep your pairs together. So this goes here. Okay. So here we go. M1 V1 equals M2 V2. And M1 is 12.1 molarity. And V1 is my X. And M2 is 1.50 molarity. And V2 is 250 with 4 significant digits, by the way. That's an after zeros, and that makes a sandwich, so all 4 count. Turns out, though, I'm going to go with 3, because this has 3, then zeros after, and this one has all digits. So between 3 and 4, I'm going to have 3 significant digits. But I'm getting ahead of myself. I want to just isolate my X. So I'm going to divide by 12.1. And check out what happens to the label when I divide by 12.1. This molarity and this molarity cancel, and some milliliters is the label for my answer, which is great. That works. I put milliliters in, I get milliliters out. If I put liters in, I get liters out. That easy. Okay. So my volume, which is my X, is 1.5 times 250 divided by 12.1. So I'm just going to plug that through my calculator now. And with 3 significant digits, I'm going to get 31.0 milliliters. Again, milliliters can cancel. That's how it's milliliters. Just be careful. Don't accidentally call it liters if you put in milliliters. Be careful. Again, milliliters in, milliliters out, liters in, liters out. Be careful. All right. Let's try another one. Purple. Okay. So number with this label, number with this label, number with this label, and question statement. What is the original molarity? Okay. So M1V1 equals M2V2. And the original molarity means I'm looking for this. So what was the original volume? The original volume was 25 milliliters, and it's written this way. That's 4 significant digits. And my new molarity is 0.5000, which is also 4 significant digits. And my new volume is 250.0 milliliters. Okay, which is good. I need these 2 to match. right? I need the milliliters only. If one was liters, one was milliliters, I'd have a problem. All right, so we are good to go. M1V1 equals M2V2. And I have X times 25 milliliters. And I have 0.5000 molarity times 250 milliliters. I'm going to isolate my X by dividing by 0.5 milliliters. It reduces to 1 on this side. And here's the math I'm going to do. 25 times 250, divide by 25. 25 times 250, divided by 25. Now, here's the thing. To the guess, my original molarity comes out to be 5. But all my numbers have 4 digits, so I need to add some more significant digits. Easy enough. 0.000. I started with 4 everywhere. I should end with 4. That easy. Just ending with 4 significant digits. Milliliters as a label cancels, so the molarity here is what gives me the molarity there. All right. So there's that one. So let's move on to the color of it. Yes, we'll go with white. Okay. Okay, so I'm circling numbers with their labels. I like to annotate when I can, numbers with their labels, just like that. I like to annotate when I can, so it's that easy. And then I find the question statement, new concentration. Now remember, concentration is molarity. So much for a new molarity. Okay, so M1V1, M2V2. And my original molarity is 3.57. And my original volume, because we want those pairs, watch out for those pairs, keep the pairs paired up, 1.55 milliliters. And I'm looking for new molarity, and I have 355 milliliters. Okay. So M1V1 is 3.57 molarity. Equals X, that's what I'm looking for, and 355 milliliters. So to isolate my X, I'm going to divide by 355 milliliters. It's the 1 over on that side, but just have X, I have 1X, and then milliliters even reduced. So by the way, 3 sig digs on each of those if you didn't guess. Okay, so 3.57 times 1.55 and then divided by 355. And I'm going to feel like this is going to be a small number. And yes, it is. And that's okay. Molarities can be big and molarities can be small. Probably over 100 is huge for molarity. I wouldn't assume a molarity would ever be that big, but they do tend to be small. Anyway, so the molarity I was looking for is, okay, that here is a placeholder. So here we go. 1, 5, 6. There's my 3 significant digits. The label that didn't cancel is molarity. Here I go. All right. And then one last one. And then you will have had a chance to practice all 4 possibilities. We've done, if you haven't noticed, we've done an M1, we've done a V1, we've done now an M2. I'm assuming there's going to be a V2. Oh, look at that. It says how many liters. It's as if I knew what I was doing something. Okay, so, let's go turquoise. Here we go. Let's turquoise. I've got a molarity. That's the number with the label. I've got a liters. That's the number with the label. I've got a molarity. Okay, number with label, number with label. I actually did this in the lab myself. I ran out of vinegar, so I just mixed up my own. So, M1V1 equals M2V2. Because for some reason I have lots of bottles of really concentrated acetic acid. It is really concentrated, 17.1 molarity. That's a really high molarity for typical things we'll find in a laboratory. But we want to keep the pairs together. Okay, so these 2 are pairs. And so I've got to put this as my volume one, if I call that my M1. That's the key. My new molarity is that, and I'm looking for V2. So there we go. M1 V1 equals M2. Molarity 0.500 liters. Ooh, it's in liters. Okay, we'll talk about that in a moment. By the way, 3 sig digs and 3 sig digs on those numbers so far. So here we go, 0.0900 molarity times that. I want to isolate my X, get that by itself. So I'm going to divide both sides by 0.900 molarity. That's the one which isolates my X. My molarity even reduces to 1. I'm going to take 17.1, which is 3 sig digs. I'm going to multiply by 0.5, which is 3 sig digs. And I'm going to divide by 0.9, which is 3 sig digs. Okay. And here is what I get. By the way, I'm looking for volume. We'll talk about that in just a moment. I get 9.5, but that's only 2 sig digs. And I have 3 and 3 and 3, so I want 3. Okay. I'll just add a significant 0, and then it works. So this is how accurate I can be. That's what significant digits tell us, is the accuracy. That's just how accurate I can be, not just to the 10th place, the 100th place. I shouldn't add more zeros because I'm not that accurate. Okay, the rounding occurs here in the 100th place. Now we all know. The label, because this is a volume, the label is the one that can cancel liters. Now notice this time was liters and the previous time was milliliters, and that doesn't matter. Again, please be careful. Milliliters in, milliliters out, liters in, liters out. This time I have liters in, so it's going to get liters out. The way that's going to work. Let the labels help you and guide you and tell you what you're going to get. Okay. That is it for our discussion of molarity for finding concentration numbers and then using molarity to calculate dilution. It tells me how much, in this case, it told me how much of my created in lab vinegar that I can make. And I can make a lot with a small bottle. But vinegar is actually really dilute to begin with. So there is that. Notice how low the molarity is, 0.9. Okay. So that's how we use molarity. That's how we do dilution. Two really simple equations. So just be careful. Be very careful that you can isolate your variables. Be very careful you watch out for those labels. All right. Hope that went well for you. Good luck. I did not clear my